lot of things that you know about every element. These are what we call nonmetals. And then we jump over, and then the P's, we've got P, because I'm going to teach you so many secrets today. It's funny, students often come into my class and say, do I have to memorize the whole periodic table? And the answer, of course, is no. But there are so many little hidden secrets in that table I'm going to teach you about starting today. So let's get right into it. What is the periodic law? It is this: when you arrange elements in this fashion, did you ever notice the odd shape of the periodic table? Why is it shaped like that? Why does it have the same number of elements in every row? Did you ever wonder? Well, when you arrange it that way, these patterns appear, and similarities in physical and chemical properties, those patterns appear repeatedly. That's what periodic means. So let's get into the first one. First of all, there's a lot of things that you know about every element in the box, right? Atomic number, symbol, atomic mass, name, and so forth. What else do we know? Well, there are what we call periods, and those are the rows. And so there are 7 periods. I'm going to number them here. And if your table's not numbered, go ahead and write on that and number that. And then we have groups. The groups are the vertical columns. And so there's groups 1, 2, and then we have 3 to 12, and then 13 to 18. So there are 18 groups. These are also called families. And I had a periodic table that had like a little, what I thought looked like a little roof over every group or family. And it made me think of how people in the same family live in the same house, and they have similar characteristics or mannerisms or things like that. So elements in the same family behave very similarly. They can even look alike. Chemically, they are alike. So groups and families. Now, let's keep going. Some of these groups or families have special names. First of all, let me pull hydrogen out. I'm going to pull him out right here. Hydrogen, he is not in this little group. He is a nonmetal, and he doesn't really belong here. But underneath, those are what we call the alkali metals, that first little column. That second group right next door are the alkaline earth metals. And then we get to the D block. I'll label that up. Remember the S, D, P, and F blocks? Well, the D block, those are the transition metals. Most of the things that when I say metal you think of, like copper and zinc and silver and so forth. And then go to the far end of the P block, and we've got the halogens starting with fluorine, and then the noble gases on that very last column. Now, the other thing that we can tell from the periodic table are metals and nonmetals. And there's like a little stair step. It might even be in your on your periodic table. You might even have a little divider there. And so these are what we call nonmetals. And then there is a little buffer, if you will, right here, which we call metalloids. And then what that means is that everything else is a metal. And so you can look at the periodic table and tell if something is a metal, a nonmetal, or maybe a metalloid. Let's keep going. You can also see, this is one of my favorite things, the ending electron configuration. Okay, you worked really hard to figure out electron configuration. So here's the secret. Everything in that first column ends with, S1. And I'll just label this one for you. So this ends with S1. So this guy down here is 2S1. This one is 1S1. Right next door, that guy ends with 2S2. And then we jump over, and then the P's, we've got P1, P2, P3, all the way to P6. Now this is hydrogen, and he's just 1S2. I'm sorry, helium. So hydrogen, helium, give them a little grace here. All right, so there's the ending. These guys all end with something P1, right? Down here at the bottom, it would be 7P1. And then what about the D's? These guys end with D1, and then this was D10, and then F1 all the way to F14. How cool is that? So you can look at the periodic table, find an element, and determine his ending electron configuration. For example, this guy right here, that would be scandium. He ends with 3D1. All right, let's keep going. Valence electrons. This is a new definition that you need to know. Valence electrons are the electrons in the highest energy level. So we're talking N equals 1, 2, 3, etc. So if I had an electron configuration like this one, 2p6, 3s2, the highest energy level occupied would be level 3, right? How many electrons are in level 3 here? We've got 2. So we would have 2 valence electrons. I like to abbreviate VE for those. All right, so everybody in this first column has 1 valence electron. The second column, 2. Coming over here, we've got 3, 4, 5, 6, 7, and 8. 8 valence electrons. This is going to be really important when we get to bonding. So hang on to this fact. Skip the D and F block. There's a different situation there.